Hello, my human friends. Today we're going to be talking about negative and zero exponents. Maybe by now you've learned that anything to the zero power is 1. That's my lesson about zero exponents. I hope you enjoyed it. 8 to the zero power is 1. Negative 1,278, if we take that to the zero power, you guessed it, it's 1. So anything, yes, even anything to the zero power is 1. Congratulations, you know all about something raised to the zero power. Of course, it's going to get a little more difficult than that. Let's start talking about negative exponents. And we're going to go through a little thought experiment to begin with. So, negative exponents. Well, I know about positive exponents. I know that 2 to the third power, I know that's 8. I know 2 to the second power, that's 4. 2 to the first power, that's 2 today. And we just talked about how 2 to the zero power is 1. And 2 to the, well, I get negative 1. I don't know what that is. 2 to the negative 2. I don't know what that is either. But I do know that as I'm moving this way, maybe you see a pattern. Especially as you're moving this way. I hope you can see the pattern, because we're just multiplying one more 2 as you move from right to left here. Multiplying 2, and so on. In order to move backwards then, I think you'd be dividing 2 as you go. So wouldn't it make sense that as you moved this way, you take 1 and you divide 2? Interesting. When you move again, guess what? You're going to be taking 1/2 and dividing by 2. When you're dividing fractions, you keep, change, and flip. Keep, change the sign, and let's flip. So really, you're talking about 1/4. That belongs right up here. Interesting yet again. Notice that on the bottom here, in the denominator of these fractions, you find 2, which is roughly equivalent to 2 to the first, but that says 2 to the negative 1 up there. You have a 4 down here in this denominator, which is roughly equivalent to 2 to the second. Interesting. So let's explore what this property actually tells us. So you can see here that we have any number here, a. If you raise it to a negative power, negative n in this case, you can rewrite that power as 1/a to the n. It has become a positive power. And that makes sense because of what we explored. As you were moving here, we saw that we were continuously dividing these ideas by the base. So when we saw 2 to the negative 1, it was really 1/2 to the 1. When we saw 2 to the negative 2, it was really 1/4, which could be expressed as 2 to the second. And when you see 2 to the negative 3, guess what? Because of this property, it's 1/2 to now a positive 3, which is 1/8. Really cool stuff. Made some room here to talk about this rule as it applies to different circumstances. So if you have a to the negative n, and you have a fraction like this here, and maybe you have a 3 involved, you can keep the fraction just as it is, except for take this term here, or I should say this variable here, this power that has a negative exponent, and put it on the opposite side of the fraction bar and make it positive. So that's a positive a to the n. So what's an example of that? Well, if you have 15b to the negative 5 over 3b b to the fourth, right away what I would do is identify my negative powers. If I have one, I can just put it on the opposite side of the fraction bar. So this here is the same statement. And then do any simplification that you need. So it looks like you can divide the top and bottom by 3. When you do that, you're left with a 5 on top and a 1 on the bottom. When you multiply those b's together, you've got b to the 9th. If you're more of a formula person, know that you can piece apart this fraction by saying 3 over 18 is multiplying c. And remember the formula for attacking variables, powers, that are being divided and have the same base. This is the same as saying a m minus n. So up here when you talk about c, you can say 2 minus 8. When you talk about d, you can say 11 minus 7. Okay, we're on our way here. For the number part of things, when you divide these two ideas, you can divide each of them by a 3, and you're left with 1 on top and a 6 on the bottom. So this is really 1/6. And you've got c to the negative 6, it looks like, and d to the 4th. Okay, well, c to the negative 6th is really 1 over c to the 6th. And you've still got the 1/6 out in front. And you've got d to the 4th, which is really over 1. When you multiply these ideas together, you should be left with d to the 4th over 6c to the 6th. Okay, well, maybe you've noticed, but this is actually supposed to be a d. Let's pretend it was the whole entire time, because I was pretending it was a d the whole entire time. So there you have it. That's been a d this entire time. I hope it hasn't bugged you too much. Okay, humans, here's another example, and hopefully this brings home the idea we're trying to get across today. You've got a fraction, you've got a monomial on the top, a monomial on the bottom, and you want to divide these things. So 18 divides 6, you can separate this. Numbers with numbers, variables with variables, so long as they have a like base. You see the b's here, where you have 5 on top, minus, be careful here, minus a negative 1 for the b's. And with the m's, you have m, a negative 3, minus 2 is the exponent for m in the denominator. Okay, it's that simple. 18 divided by 6 is 3. The b idea, this becomes a plus sign right here. So it looks like b to the 6th. And then you have m, same sign sum, to the negative 5th. The only thing you need to worry about now is multiplying these together. However, you notice you have a negative exponent. So this becomes 1 over m to the 5th, positive now. And you're still multiplying 3 times b to the 6th. Both of these are over 1. So it makes sense that it's 3b to the 6th on top, and you have m to the 5th on bottom. Not too shabby.